In this lecture, we're going to continue our examination of measurement and sampling by revisiting and covering some key concepts. And so when we talk about data, data refers to scores, numerical values on variables that allow us to take this quantitative approach. Variables refer to traits that can change values from person to person or just simply referred to as case by case. And some examples of variables include gender, age, religious affiliation. Cases refer to the entities from which data are gathered. And so data can be gathered from people, and each person would be considered a case. If data are gathered from a range of businesses, each business would be referred to as a case. The same with cities. So if we conduct a study examining crime patterns in 30 different cities, each city would be considered a case. And likewise, another example would be countries. And so in applying this idea here, we see that in a recent survey of university students, Statistics Canada found that the average age was 21.7 years. And so in identifying the variables, the data, and the cases in this particular example here, we see that age is the variable in question. In terms of data, the actual cases that were sampled, that were available to Statistics Canada, refers to the actual data, and the cases are the individual university students. In terms of statistical applications, there are two general approaches that are used to begin the process of answering these research questions. The first approach is descriptive in nature. And so descriptive statistics basically just describes the basic characteristics of a person or a group. And so data can be summarized on one variable. If it is, that is typically referred to as univariate. And some of these statistics include the average, the standard deviation, or the median. If the question involves two variables, then another descriptive approach could be the examination of the relationship between two variables. And oftentimes research studies have three or more variables. And in those studies, we often make reference to a multivariate approach to answer a research question. Oftentimes, research investigations want to take an inferential approach, and inferential statistics refer to another set of equations and formulas that will allow us to draw more cause and effect conclusions to the research question. And so the term implies that we are inferring the results of an analysis to a larger population. And this involves what's called statistical hypothesis testing. This is very different from generating the research hypothesis, and this is something that we'll address a little bit later. The inferential approach also involves the generation of descriptive statistics first. And so if we take a pure descriptive approach, we are not generating inferential statistics. However, if we take an inferential approach, we're also generating descriptive statistics. Some research designs, some research questions do not require the inferential approach. And the inferential approach is critical if the researchers intend to establish a cause and effect relationship between two or more variables. To understand quantitative data is to understand the difference between discrete and continuous variables. So the discrete variable is one where the units cannot be subdivided. And in a sense, there are gaps that separate, very clear gaps that separate different values on a particular variable. And in this case, there are no fractions between the units that can be used to quantify some variable. So the variable is classified in whole units. One example or two examples of discrete variables include what are called dichotomous variables or categorical variables. One example of a dichotomous variable, if defined by researchers to have only two possible outcomes, might be male and female. If we extend the definition of gender, then it is no longer dichotomous. It would be categorical, where there would be more than two categories. But anytime we see the word dichotomous, di meaning two. In terms of scores, whole integers are often used. And so in a research study, although we use, in this previous example, verbal descriptors are used, when it comes to entering this variable into a statistical analysis, the categorical, or in this example, dichotomous variables are often quantified, used, and coded with numerical values. Another example refers to the number of people per household and where whole numbers are used. And so there are very clear gaps between 0 and 1, 1 and 2, so on and so forth. The other type of variable are continuous variables. And in theory, these involve units that can be subdivided infinitely. So the variable actually takes on a value along a continuum. And so there are, in theory, no gaps between possible values that a variable can take on. And so there is an infinite number of fractional components. And in this type of approach, oftentimes the testing instrument is limited by its precision. So one example is age. So age can be measured using whole units, but if we quantify age in years, however, we can generate a greater resolution of the measurement of age by including months, weeks, and or days. Two other very important variables include the dependent variable. Anytime we engage in research, there's always an outcome measure that is of interest to the researchers. So some examples of these outcome or dependent variables might include the results of a federal election. And so in this particular case, here we see three different parties, and the outcome of the election aren't the individual parties, but rather the number of seats won by each of these three respective parties. Another outcome variable is if a researcher is interested in the number of SARS-CoV-2 infections in Ontario. And so the outcome is actually a count of the recorded number of registered infections up to and including a particular date. The median household income in Ontario is another outcome. So the actual outcome is a numerical value. In this particular example, sampled a few months ago, is the pre or before taxes median income. The independent variable is a variable that will influence the outcome. So the dependent variable will, or the variable in this case, the outcome will depend on the independent variable. And so some examples of this include political campaign fundraising. That would be the independent variable in this research question. The outcome would be the party's share of votes, or the dependent variable. So if a cause and effect relationship did in fact exist, the amount of fundraising that a political party is able to engage in will translate into a greater share of the votes cast for that party. Residential location would be an independent variable in predicting the number of SARS-CoV-2 infections in various regions, in various cities. So in this particular case, we're examining once again here how the number of infections will depend on residential location if that relationship did exist, that we would have to evaluate quantitatively research that would specifically investigate that question. Another common question that is often addressed in research relates to the level of education that will determine household income. And so the outcome here, the final variable of interest, is the household income. And how can the level of education either predict or cause an increase in household income? So this ends our second lecture here for Unit 4.